My name is Aboli, and this video presentation is for IFT 510. I will be illustrating a batcher-banyon network which uses a binary method to route network traffic from one input port to corresponding output port with no collisions. To illustrate this, I will walk you through this Python script that I have created, and it basically has two parts. First of which is the sorter down here. It takes user input and it's indexed from 0 to the number of ports -1. So in this case, 0 to 7, and randomizes it. Here's the index that provides us a key value pair for each port and their starting nodes. Below is the display for when the computation is all done, and above is the actual networking piece that ties or routes traffic based on the binary value. I will show a screenshot with a test case that I have already produced, and then we will run through this code and make sure that the input is valid and it does what we're expecting. So the method by which the Banyan batcher network does this is it takes the binary equivalent of a number and routes traffic directly across, as we would see here. So for 0, if it is 0, it'll go on the upward side of the traffic, and if it is 1, for every time it's 1 for the binary representation, it'll go under. And I'll use a few test cases here and take a look at this side here. So user input 7, this is the part where it does the sorting, and now it gives us a key value pair for this input, this port, this input, that port, and I'll show how it aligns. So from input port 0 to output port 0, the route is A1, B1, C1. As we can see here, A1, C1, B1, C1, all of those binary values being 0. The next path here is input port 1 to output port 1, and the route is A2, B2, C1, and I'll show how that goes. So from input port 1, but the first binary equivalent digit would be 0. So it goes up. Next one, 0, goes up. And finally, 1. Here, C1 down, and so on and so forth. Ignore the scratch mark here. I previously traced this wrong. So I'll go back in the code now, and we will run this code. Requesting a number of nodes. Actually, it should be number of inputs, but let's say 8, because we're going 0 to 7 for 8 total, and it gives us corresponding routes for which traffic should go. I'm going to run this one more time again and provide it the input of 9, in which case it would do nothing because here we only sequenced 8 inputs and 8 outputs. So if we went 9, it'd do nothing. One step further, if we were to stretch this and go to a 16 port input and output, it would be a simple case of increasing the size of our list to get that many ports and randomizing that many numbers. So if we ran this module, it'll say same thing, enter number of inputs, and here we can go as big as 16, and it'll give us the same packet routing for each of those. And if we were to walk through this using the logical model that I just showed here, we'll realize that the same routing was successfully achieved with no collisions. Thank you.